All right.
Check it out. Just like do it by mental. Like what's the number?
All right, guys. So you'll see here very soon why I did chapter 11 a little out of order. We'll get there. I want to graph this thing. And all of us should know the shape this takes on when you graph it. But again, let's do the same thing I did earlier. If I plug in these points, I get a feel for what this thing looks like, right? So what do you get when you plug a -2 in? 1/4. You get a what?
1/4. 4.
That's right. No negative power. Negative number squared is positive. -1 squared. 1. 0 squared. 0. 1 squared. 2 squared. So to graph this, 0 is 0, 1 is 1, -1 is 1, 2 is 4, -2 is 4. You get the nice parabolic. The shape you use for spotlights, for example, right? Because any light coming in will get focused out to one point. You can use parabolic mirrors to capture for astronomy. Gather light into one point. And all that stuff is secondary. Right? This is the pure math. Right? There's a lot of uses for this shape, but this is the math. If I put extra terms in this equation, in this function, it's just going to move the parabola around. Because maybe now 0 won't be at 0, it'll be something else. If I put extra terms in there. You guys kind of with me? But what's true, why does it make sense that if 1 goes to 1, -1 also has to go to 1? Why must those points be like right there?
Because they always become positive.
Why must if I have a point there, I better have its reflection over there? Because the parabola, it's got to be symmetric. And I think you said it's sort of, if I square something and square the negative of the same thing, it's going to come out to be the same number, right? All right, hopefully, so it's symmetric. Where's the mirror going to be for this? The y-axis, which is also known as what equation? What's the equation of the y-axis? What's the equation of the y-axis? What, Jeff? If I have x equals 1, that would be the equation of this line. So what's the equation of this line? What's x? X is 0. Y equals is a horizontal line. I don't know if you guys remember. X equals is a vertical line. So this is what I call the axis of evil. No, symmetry. This is the axis of symmetry because it's the axis. It's like where I would put the mirror for the shape. It's where I could cut and it would pull back on itself, right? Okay, maybe.
So y equals, that's basically saying like the exact opposite of what we have known y to be. Y is this way. This is y. But
That's true.
If it
but
equals,
no. I'm not saying this is x suddenly. I am not. How do you graph x equals 1? How do you graph that line?
Vertical line.
Why? Because what's got to be true? X has got to be 1. What can y be? Any damn thing it wants to be. So this is the y-axis because it's the axis that has all the y values. Y can be anything it wants to be on this axis. What's x got to be on this axis? 0. It doesn't have any option. The only way x has options is if I can go that way or that way. If I'm on this axis, can I go that way or that way? No. Poor little x dude is the one that has no options. Right? All right. So I'm not saying the opposite of anything I've ever said before. I can't. If you think I am, let me know because you're wrong. Okay. So what happens if I have a little bit different look at equation here? Let's do one we can do something. Can you guys find the X-Intercepts?
No. Unless you X-Factor?
There you go. Okay, yes you can. I'm not saying, can you tell it to me without doing anything? Can you find the X-intercepts? Yes. Why do you have to factor? Because to find the X-intercept, well, what's the Y-intercept? Let's start with the easy one. What's the Y-intercept?
8.
Why?
Because it is 8. The formula is 8. I mean, the formula of X.
No, it's not a line. I can't just look here and know, but the reason that it still works is because how do I find the Y-intercept? I make X 0. So then it is 8. Yes. Because when X is 0, I get 8.
Ah, this is.
So if there's no X on
that's
it.
the way to explain it. I like your explanation. As a teacher, you just me what is it? Why is 2? Because it's 2. Moving on. That's awesome. Some days you just want to do that. Because it is. Damn it. So how to find the X-intercept? Always. To find the Y-intercept, I make X 0. To find the X-intercept, I make Y 0. This is the Y here, right? So I want to solve this equation. How do I solve this equation? Like Jose just said, the easiest way is, please, dear God, let me factor it. And of course, if you can't factor it, we now have quadratic formula. I like it. But I can factor this.
X minus 4, X minus 2.
Kick ass. So what are my X-intercepts?
4 and 2.
Yeah, 4, 0, and 2, 0. I like it. This is my X-intercepts. Now let me see if you guys can get this idea. Any function that looks like ax squared plus bx plus c has got, with a graph it, it's going to be symmetric. It's going to be a nice, perfect U shape. It's going to be perfectly symmetric around the middle. Right? Where's the vertex always going to be on a parabola? It's going to be in the middle, right? Does that make sense? The vertex has got to be that point. It's the turning point, so it's got to be right in the middle somehow. Is everybody with me so far? Some of you guys are like, wow, dude, it's amazing what you're saying. Don't be sarcastic in your thoughts that I just made up. So all I know right now are the X-intercepts are at 2 and 4. Where must the vertex be? What must be the X value of the vertex? You guys can do this. Where must the vertex be? Where does the vertex have to be?
3.
At 3. Why at 3? Because the vertex has to be in the middle. Right? And I know it's going to look like this, right? How do I know it's opening up, for example? Do you guys know that? How do I know this thing is like this and not opening down?
Because it's a positive.
Because it's positive.
Doesn't flow.
Yeah, the A piece is positive, so I know it's opening up. If I made it negative x squared, it would be opening down. That kind of makes sense. Negative slope, sort of. Slopes get a little freaky when you have curves, because they turn, right? It's not just always. Anyway. So I don't know where the vertex is, but I know that X has to be 3. Does everybody see that? Because it's symmetric. So if I know 2 points are across from each other on a parabola, the vertex has to be on the line in the middle. So if I know the X part has to be 3, how do I find the point where the vertex is?
You plug in 3.
You plug it in. I know X is 3. I plug in 3.
So if it's in the middle of something, then you know it's that.
If I know 2 points that are on the line, then the vertex has to be, that are across from each other, right now on the line of the parabola, that are across from each other, mirror images of each other, the vertex must be right in the middle of those 2. I just don't know if it's here or here. I know it's not up here because it doesn't open down. But I got to plug in 3 to see where it is. What is g of 3? 3 squared is 9. 6 times 3 plus 8. What's 9 minus 18? Plus 8 is negative 1. So I know it's at 3, negative 1. So I know my parabola goes like this. Oh, and what's my y-intercept?
8.
0, 8. So then I know my... And let me see if you guys get this. Can somebody come up with another point without doing any work like this?
6, 8.
Yeah, and we know that it goes through 0, 8. Here's the axis of symmetry. Here's the mirror. So there has to be another point equally distant on the other side. So there has to be a point 6, 8. So if I know there's one point on one side of the parabola, I automatically know there's another point mirror image on the other side. Why? Because the parabola is symmetric. So that's a beautiful thing to know. I have less work to do. Yes?
Did you just put the 3 in there just for...
No, because I knew. Where did 3 come from? 3 is a very important number. 3 is where the vertex has to be, because it's in the middle.
So G of whatever is the vertex always?
Whatever's in the middle of the two X-intercepts, right? Alright. Does that, everything I've said, or most of what I just said, makes sense? The symmetry of the parabola is really behind almost everything I just did up here. Right? The symmetry. So under 2 points, the vertex has got to be right in the middle. And then just plug that X value in to see where the hell it is. So I want to make that, can I always factor what's going to be here? No. Quadratic formula is really weird. But let's make a general process of finding the vertex. This is kind of kick-ass. And this is what 11.1 just says. Oh, this works, by the way. And it can't explain why, because you don't know quadratic formula yet, officially in 11.1. So here's the beautiful thing. I want you guys to really get this. How do I find the X-intercepts always? So if I give you this, how do I always find the X-intercepts? I find where this equals. How did we find the X-intercepts here? I set this equal to 0 because it's changed. I'll make Y 0, don't I? And how do I solve this in general? If I don't know how to factor it, what do I use?
Our system, which
Quadratic formula, right?
Hey,
What's the quadratic formula say again?
Minus b plus or minus
Alright.
b squared minus 4ac over 2a.
Hey, real quick, while I got this sitting up here, what's the only way this could come out complex? How could this come out imaginary complex? Why would there be an I? If what? If what's true about this number? If this number is negative. So if b squared minus 4ac comes out to be negative, you're going to get complex answers, right? And to tell you physically, what would that mean? That would mean my parabola never touches the x-axis. There can't be any real answers. There are complex answers, right? Because are there real intercepts? No. If it doesn't touch the x-axis, there aren't any real ones. So if you come up with a negative in the inside, don't freak out. That's your answer. It just means physically I'm not going to see them. I'm not going to see them hit that x-axis. All right, let's stay with it. All right, I really, really want you guys to get this. The thing you do is stupid easy. The reason you do it is a little bit murky, but let me see if I can't get you to get there. Can I rewrite this like this? Is that all right to do that? Can I do that?
Yeah.
Because they have the LCD, I just pull them back apart, right?
Mm-hmm.
Do you guys see how this says something in the middle, give or take that? So if this was 7 plus or minus 3, it'd be 7 in the middle, go up 3, go down 3. Isn't that what that would mean? So it would be like, whatever this number is, I want to go up some amount plus this, and I want to go down this amount, right? And then my x-intercepts would be here and here. Stay with me. Do you guys understand what I just said? Does that make sense? If you look at this equation, what does it say? It says this number, give or take this. So that's in the middle. Go up by this much, go down by this much. No.
Just the negative b over a, right?
What do you mean?
That's the vertex, right?
So
Some of you guys know the shortcut, and you're trying to, but do you see why it leads there? These are going to be my x-intercepts. Because it's this plus this, bam. This minus this, bam. So what's always in the middle of my x-intercepts? Negative b over 2a. So for example, that 3 we got there, what's b in that equation? What's b? So negative b over twice a. What's negative 6 divided by 2?
3.
Freaking 3, right?
So that's
Of course it is, because it's going to tell me what's in the middle of my intercepts. That's a shortcut. That's going to tell me what's in the middle of my intercepts. And why is that important? Because that is where the vertex freaking is. So that's a shortcut to find the vertex. If you can't factor the damn thing, and you won't be able to factor everything, right? We did that problem originally because we were able to factor it. Then it made it easy. Well, what if it wasn't factorable? Then I can do this way to find that middle number. So that's why this negative b over 2a, a lot of you guys already know it, but that's why it's a shortcut. Right? 11.1, they don't explain it. They say, hey, guess what? You can use this. That's bullshit. That's why it works. Yes?
on that top equation, when you set a equal to 0, you don't have to subtract the 8. You just set it equal to 0 right off the bat, like you did where it says the x-intercept.
Well, you could only subtract 8 once you've got it equal to 0 anyway. But once I set it equal to 0, I want to factor it because it's got an x squared.
So if it doesn't have anything, you just put it equal 0.
To find the x-intercepts,
Right.
I replace this with 0. Yes, cool. Yeah.
And what's the name of the negative b over 2a again?
It's called the negative b over 2a. It's called, it tells you the x part of the vertex. There's no name to it.
Yeah.
I mean, we can call it a name if you want, but that's what it does. That's its job, is to find the x piece of the vertex. Because what did we do here with that 3? That 3 wasn't the vertex, because the vertex is a freaking point. So once I found the 3, what did I do with it? I plugged it in to see the other part of the point, right?
Yeah.
See where the vertex really was.
Yeah. We recognize x, but later on we have to recognize
We have to get y. Yeah,
Yeah.
the whole point.
Yeah.
Yes.
So when you're finding the vertex, you need to graph it like that. You can't.
At the end.
Oh,
So let's do a whole problem out.
okay.
Let's pull this in. We know how to find x-intercepts. We know how to find y-intercepts. And now we know how to find the vertex. And that's all I need to graph. That's even more than I need to graph a problem. So let's try one. Here we go. Stay with me. Let's try a couple of quick fire ones where I just find the vertex. I want to make sure everyone gets it. So if I have this, all right. Can you factor that? The short answer is no. You cannot factor that, just to get to the point. So how do I find, so the question says, and this is going to happen to you in the homework, they're going to say, find the vertex, and that's all they ask. They just want you to find the vertex. So I can find, I know the vertex is in the form xy. I know it's a point. So I can find the x piece of it first using that shortcut we just came up with. I just have to identify b and a correctly. So what's b?
24.
Negative 24. So negative that. Negative 24 over twice a, and a of course is 4. So I get x is 3. Good. 24 divided by 8, 3. So I got the x piece of the vertex. That's what negative b over 2a does for me, is it finds the x piece of the vertex. Why does it always do that? Because negative b over 2a will always be right in the middle of the intercepts. Just like we did there. How do I find the whole vertex?
Plug in x.
Yeah, I know x is 3. So now I just plug it in. So 4 times 9 minus 24 times 3. 72, that's right. So h of 3. Is it very cool what I'm doing now? So this only finds you the x part of the vertex. Any vertex is a point and needs 2 parts. Well, if I know x, how do I find y? I just plug it in. That's how I always find y. If I know what x is, I plug it in and find y. So I'm plugging 3 in. 3 squared is 9 times 4 is 36. Minus 72 is 36 minus 72 is negative 36. Plus 7? Negative 29. So what's the vertex?
3 to negative 29.
3 comma negative 29. That's the vertex. What's up? How we doing? Some of you guys just can't believe it's that easy. Yes.
That's what I was just going to ask. So when it just asked us to do the vertex, we use
That's all. If it just asks you to find the vertex,
and then
that's it.
When it asks us to graph it and find
Let's
the
go ahead and graph this one too. I'll show. Let's graph this one also. What's this guy's y-intercept? How do you find the y-intercept?
Plug in the x equals 0.
Yeah, if you make x 0, so it will always be this number. It's very much related to b from the linear, from y equals mx plus b. Because you make x 0, the mx piece goes away, you're just left with b. So if you make x 0, these are going to go away, you're just left with whatever the hell number that is. So the y-intercept is 0, 7. Oh, yeah. Well, let's see. Let me do this. Let's do 5, 10, 15, 20. You see y here, right? Negative 5 and negative 10. negative 15, negative 20, negative 25, negative 30. Because look, I got to get to negative 29, right? So your scale, do I have to do 5, 10, 15, 20 here?
No.
No, thank God. I don't want to, right? I only got to go out to freaking 3, right? 1, 2, 3, 4, 5, 6. 1, 2, 3, 6. There you go. Yeah. So where's my vertex? 3, negative 29. 3, negative 29. So about right there. All right, we stop there, right? Is that cool?
Mm-hmm.
Where's my Y-intercept?
0, 7.
0, 7. Where's one more point that I can get without doing any work at all? There's the axis of symmetry here, right? One more point.
Go the same distance
1.5.
you did that way, the other way.
So
1.5.
where is it going to be?
6, 2, 7.
6, 7. I like it. So this is the point that we got by symmetry very quickly. Because it's parabola symmetric. It's got to be like a mirror image. So you can always find the y-intercept. The y-intercept's easy to find. Hell yeah, just make x0 the y, and then you get an automatic second point that's easy to find. It's just the same distance on the other side. It has to be. So then I make my, in this case, big ass parabola, big old parabola. I dock it. What's the axis of symmetry equation? It's not x equals 0, it's x equal 3. There, see, let it be easy. That's the axis of symmetry. X equals 3 is the axis of symmetry.
Oh,
Well, yeah, I like that. I like that. Well, yeah, that's what I say. Yes.
Is there an equation to find the mirror point? Because what if there's fractions? How do we find the mirror point?
Who cares?
Just count.
Who cares? Yeah, just count. Yeah. I mean, you could create an equation if you wanted to, but it's, I don't care how ugly you make things, you just go the same distance. Yeah. Okay. Let's see. Let me give you, let's talk about this. Let me see. Let me get a nice one here. Yeah. Gross. No, that's not good. I was excited for a second. Oh, here we go. Perfect. So if you were on the moon and you threw a baseball, could you throw it further or not as far as you can here? Why could you throw it further?
Because there's no gravity. I mean, that's gravity.
Less gravity.
Further on the moon?
If you're on the moon.
You throw it farther?
Of course.
Really?
Yeah.
Why can't I throw it as far on Earth? Because gravity is strong. Gravity. Oh, I said gravity. It sounds like I want some gravity. If you're on the moon, gravity is not as strong. That's why when you watch the old things, even if you think that it was filmed in a soundstage, they did a pretty good job of, because they take a step and you're like flying. Hello, they could pick their lunar, yeah, because it's not as heavy, right? Because mass doesn't change, but weight does. There's less gravity. Oh, yeah, all that crap. Don't worry. It's not going to suddenly become a science test or something. But I'm trying not to cry too much. You guys should know that, the moon. So if I'm on the moon, here is the equation for the height of something I throw. Throwing a baseball, yeah. Alright. So why is it negative, do you think? Because gravity is doing what? It's trying to pull it back, right? On the Earth, this number would be negative 16. And that relates to how strong gravity is on the Earth, right? The moon is a smaller number because the moon's gravity is not as strong. It can't pull back on things as well.
It's gravity now. It sounds kind of stupid, and weight is a measurement of gravity. Well, like what's 16 toward that? You know what I mean?
Well, all right, so 32 feet per second is so on there. If you drop something, does it get faster and faster?
Yeah, totally.
So if you drop something, every second it'll pick up another 32 feet per second. So 1 second later, it's going 32 feet per second faster. Another second later, it's going 32 feet per second faster. That's acceleration. When you accelerate, you change your velocity. So 32, and there's a 1/2 in the equation because calculus. So that's why there's a 16 for Earth, right? On the moon, it's a different number. It's not 32. It's a different. It's double this. It's a, so that's why it's this. Right. Anyway, the main thing I want to talk about was this is a smaller number because it's not as strong on the moon.
So it's falling at like a constant rate and it's not accelerating is what you're
No.
saying?
It's falling at an accelerating rate because every second it picks up more velocity.
No worries. I'll figure it
Okay,
out.
all right. Do we need to know any of that? No. I like everybody's looking away like, all right. All right.
Is that equal to 0?
No. So what's the question? The question is, what's the highest point that the baseball reaches? Right. So what would this look like? Don't graph it beautifully, but if you graphed it, what would it look like? What would the shape be? Upside down. Why is it upside down?
Negative first number.
Yes. And isn't this the shape that a ball would take if you threw it? What, math has something to do with real life? Shit. That's no good. It destroys my whole preconceived notions. Sorry. That was stupid. Oh, too bad for me. So, how do you find that maximum height? What is that maximum height also known as? The vertex. And what's the shortcut to find the vertex?
Negative B.
Now, I got different letters in here, right? So what's taking the place of X? Why do you think they use T? Because it stands for time. You let so many seconds go by and you can see where the baseball is. So I don't let T equals negative B over 2A just because I'm using T, not X, right? Don't freak out about that. Just who cares what variable I'm using? Just use the same variable. What's B? 66. And what's A? Negative 2.55. I like it. So somebody help me out. Do that in your calculator. What is it? Sorry? 5.1. 5.1. No.
Yeah, wouldn't it be 5.1?
Negative
5.1?
No.
Why not?
No, because it's not. I don't understand it. Yeah, so it's 66 divided by 5.1. I don't know what you guys are doing.
Yeah.
12.9. Oh,
So you,
negative 12.9.
that sounds better. So positive 12.9, right?
Or positive.
You guys with me? I don't know if you guys did this divided by this times this
We
maybe.
didn't distribute it, that's fine.
Huh?
We didn't distribute it, that's fine.
Oh, okay. You gotta be careful
But
about.
why is it not negative?
'Cause-
Isn't that negative 66?
Negative 66 divided by twice negative 2.55. The negatives
Oh, cancel.
cancel. Yeah. What does that mean? What does that mean? That's the time. So 12.9 seconds after I throw it, it's going to get to its highest point. How do I tell where that is? How high is that? Yeah, I know the time. I can plug it in to see what the height is. So the height at 12.9 seconds, I plug it in. Right? And again, you guys have calculators. So you can do that. I'm trying to do it in my head, but it's like 300 or something. Is that right?
You can do that in your head.
Yes, for the most part. I got kind of tired in the middle. Trying to estimate it, I don't know, so I'm probably really far off. Yeah, I get like 367. But it's off. I don't know. I'm okay with being off. I'm tired. What time? What is it? Is anybody doing it? Or am I just standing here looking at the board? You guys have calculators, right?
I want one.
Able to? No, okay. It's okay if it's not the same as what I just said.
I don't think I got it right, but I got 6.22.
No.
No?
433.
Am I missing something?
Sounds about right. I wasn't too far off. It sounds right. I don't know if it is right. But it sounds right. Oh, I'm sorry. Oh, man. Here. For what?
433.1.
Sure, it sounds about right to me. And the units they use, I didn't tell you what units they use, but feet, I think, right? Feet, yeah. So after about 13 seconds, it would get up to about 430 feet on the
Yeah,
moon.
433.
Cool, I like it. Confirmation. So a baseball game on the moon would be interesting, right?
So the 12.95, did people get that from timesing 2 to 2.55, or did they get that from dividing it?
Doing what now? Sorry.
See how you got 12.9?
Yes.
Is that?
Seconds.
Did
Yeah.
people get that from timesing the 2 in the?
Well, you got to do 66 divided by 2,
Okay.
and then divided by this also. I think people did 66 divided by 2 times this, but it's not times this. This is on the bottom, so you divide it by that. So you put in the calculator 66 divided by 2 divided by 2.55, you should get 12.9 right. All right, the negatives cancel, so I don't have to worry about this. Yes, sir.
Would things travel slower on the moon because they're not accelerating from the gravity of the arc?
Do it again.
Would things move slower on the moon because they're not accelerating at the same rate?
Oh,
as the gravity of the arc?
yes. It's interesting. It would slow down slower and then speed up slower.
Yeah.
Does that make sense?
Yeah.
So when I throw something on Earth, it slows down pretty quickly because gravity's strong, and then it speeds up quickly. On the moon, it go, it start off like,
That's like why they use the slingshot around.
Well, yeah, they use the slingshot because they use anything to slingshot that they can, right? They get the gravity. It's like, they use the moon to slingshot satellites. You guys know that, or the sun even. They use the sun to slingshot. You go around and you speed up and you fly off.
Yeah.
It's like swinging something around your head to throw it.
It was like the one that went to Pluto. They shot it around the sun first, and then it came.
Exactly. All right. I like that. Oh my God. Okay. So that's section 11.1. So they're going to ask you to find the vertex. They're going to ask you to find the axis of symmetry. I don't know if some of you guys realize that once you know the vertex is the same as the x piece of it, right? That's the axis of symmetry. It's got to run through that x piece. Okay, so I'm going to let you guys try those. Last little thing. And I'll let us out of here by 12. Last little tiny thing here. Let me see. Do I want to get into it now? Maybe not. Maybe I'll let us out now. How's that sound?
I don't know if my
Yeah,
brain
it's
is
Does that sound right?
Yeah.
You sure you're going to be okay?
I'm like,
No, but it sounds good though.
Friday.
Yeah.
I gotta pick up my kids.
Everybody got a practice test, right? Everybody got a practice test?
Monday, right? Yeah, let's say just anytime. I'll be home.
Oh! Hey guys.
All right, cool.
Real quick. This is, and we'll just give it to you. You can use it or not. It's all about chapter 11.
Still looks like crap. Yeah, it's gonna be fun. It's gonna be a fun weekend.
Oh, I got one.
Yeah, I might have to go on sweater with this.
You don't have a kit for the kit? Practice kit?
Yeah,
You don't have this?
No, that stuff's not.
So you're saying the key.
Like I always do, I give it to you the next time.
I'm hoping it doesn't rain this weekend. Hoping it doesn't rain. I'm only in San Diego for one more weekend, so I want to go hiking.
Oh yeah, you